So good day. Today I'll be discussing experiment number 2 entitled Data Types and Creating VI. Um, my name is Laurence Navarro, course and section CPE109L, section E01 from group number 4. So date of performance is on December 3, 2020 and date of submission is December 6, 2020. Engineer Cyrel O. Manlises, professor. So again, I am Laurence Navarro from CPE109L, section E01. So today I will be discussing first is the step-by-step procedure. Second is the questions provided in the PDS. A. Introduction. B. Objectives. C. Materials, components, software use. D. Procedure. And the third one is the answers to questions. First is the step-by-step procedure.
So for the step-by-step procedure, here is the laboratory manual. So objectives of for the part 1 is to open an existing application and to list and define all the functions in the existing application. So for the page 2, download and unzip the attached file. So for this case, I already downloaded the file, which is here in the laboratory experiment 2. So next, open existing project. So we can by lab view, open lab view, and then open existing, and then go to the where you downloaded the attached file, and then create and use sub vi, this one, and then press OK. And there you go. And then next is to, there you go, choose the project file. Already done that. Double click the main vi. So next, so press Ctrl T to show the block diagram there. So page 7, click the run icon, run, and then a file dialog box will pop up on the screen, and then type temperature. Okay. And then next, so there will be a graph in the waveform chart, a continuous graph, and then it is set to minimum value of 0 and a maximum value of 100. So click stop button on the block diagram to finish reading the temperature. So press stop. There you go. So page 10, created sub vi folder where you save the temperature and open with notepad, and then answer the questions provided. So next, so open the temperature file, notepad, open with notepad. So as you can see, the different values for the on the graph is stored here in this file, wherein its unit is in degrees Celsius. So for the part 2, so let's move on to the part 2. Part 2, creating a temperature VI. So for the part 2, on the project tab, click create project, and then blank project, then finish. And then in the project explorer, right click, select new, and then the IQMA task. So acquire signals, analog input, temperature, and then thermocouple. So after pressing thermocouple, select under PCI 6221, select AI1. And then next, name the task thermocouple. Finish. And then here, there will be a dialog box. And then configure the task shown in the following figure. Use the setting for the thermocouple, which is set this to 30. Set this to 20. And then degrees Celsius, J, joules. Constant, set to 27. And then it's already okay. And then next. At the top pane of the dialog box, switch the display type to chart. Okay. Switch this to chart. And then run. There you go. There will be an output from the thermocouple. So, after this, on the project menu tab, click to add project. So we can now close this. Press OK. So there you go, the thermocouple. And then on the project menu tab, click add to project, new VI. Project, add to project, new VI. There will be a block diagram as well as the front panel pop up. So click save. So for this case, I have already saved that. So click the block diagram, right click to show the different functions. Go to measurements, drag and drop to start. So go to block diagram, right click, measurements, measurement, NAQ, start. Okay. Create constant, set the constant to thermocouples. Create constant, set the constant to thermocouple. Okay. So next, drag and drop the read in the block diagram. Read. Read. Channel type, analog input, single channel, single sample, then DBL floating point. Analog, single channel, single sample, and then DBL. Clear task VI, so measurement and ID, clear task, clear. Simple error under dialog user interface. Simple there we go. And then create indicator, rename the indicator current temperature. So we can press this, right? Then create indicator. Oh, sorry. There you go. Current temperature. Current temperature, degrees Celsius. Wire all the input as shown in the diagram below. So we can wire this through this, and your error out to error in, error out to error in, and then task out, task in, task out to task in, and then it's done. So for the next, modify the block diagram. So first is the greater. Greater can be seen in the comparison, and then press greater, greater. There you go. And then input terminal, right click the Y input, select create control and rename, create control and rename to maximum threshold degrees Celsius. So for the threshold exceeded, so Boolean indicator, create indicator, threshold and then select function. And then we can connect this to here. And then connect this to here. And then add constant string constant here. System in danger of overheating. Turn on the fan. Turn on the fan. String constant, system is normal. Connect this to here, and then connect this to here. And then last is the message. So the message is a string indicator. Right click the output and then right click here, string indicator, select create indicator. Okay, and then rename this to message. Oh, it's already done. So this ends the step-by-step procedure for the laboratory experiment 2.
So second, proceeding to questions in PDS. First is the introduction. So laboratory experiment 2 tackles on the different data types as well as how to create VI. So the activity consists of two parts. The first part aims the students to familiarize the different icons used in the pre-built program. Meanwhile, the second part mainly focuses on creating a temperature VI. So the experiment also discusses how to create custom components such as the thermocouple. So the thermocouple serves as the input variable signal of the program where it gives a certain temperature in degrees Celsius. So different DAQMX devices will also be implemented in the temperature program such as start task, read task, and clear task. For the objectives, first is to open an existing application or the pre-built program provided in the laboratory manual. Um, that is for the part 1. And second is to list and define all the functions in the existing application, which is also for part 1, where we are asked to list all the functions used in the pre-built program as well as to define or to give their uses on the overall function of the program. So third is to create a temperature VI. Fourth or last is to modify the created temperature VI containing certain conditions as well as signal devices. So C tackles the materials, components, software used. So the materials used in this laboratory experiment is the LabVIEW 2020 by National Instruments. So a pre-built program, as I said a while ago, it was also provided in the part 1 for the students to understand and explore different functions of the EQ devices of the library. So for the procedures, part 1, first is to download and unzip the attached file, launch LabVIEW 2020 from Windows. So next is to open existing project and choose the project file. So for this case, the file name of the project file is create and use sub vi with an file extension .lv proj or lv project. So third one is to double click main.vi, then the front panel and block diagram will display or pop up on the screen as shown in the figure. So fourth is to click the run icon. A dialog box will pop up on the screen and type temperature and click OK. So fifth is to click the stop to finish the reading. And then after this, we are asked to answer the questions provided in the manual, which I will show my answers later. So the again procedures for the part 2. First is to create the project, blank project, and then finish. Next is to create an NIDAQMX task. Right-click my computer and select new NIDAQMX task as shown in the figure. Third is to create new dialog box that appears. Select acquire signals, and then under acquire signals, select analog inputs, and then under temperature, choose thermocouple. So clicking thermocouple will proceed to the next dialog box, which the user will prompt to select a physical channel to use with the task. So for this case, under PCI 6221, select E01 and click next, as shown in the figure. And then name the task thermocouple and click finish. So after clicking finish, we will proceed to the settings of the thermocouple. So for this, we are asked to follow certain settings provided in the manual, which are as follows. Oh my god. For the settings, for the max signal input range, we are asked to change it to 30. For the minimum input range, we are asked to change it to 20. However, for the CJC value, we are asked to change it to 27. So after this, press OK. So for the seventh procedure, on the project menu tab, click add to project, new VI, and then under new VI, select front panel and then select new VI, and then front panel and block diagram are displayed on the screen. So for the eighth procedure, click the block diagram, right click to show the different functions, go to measurement in IO, and then under NIDAQMX, select the start task in the block diagram, and then drag it to the block diagram. So next is to set the input to the recently created thermocouple, and by we can select the input by right-clicking the task in the input part of the start task, and then select create constant, and then under create constant there will be a drop-down box or drop-down arrow, and then choose thermocouple as shown in the picture. So 10 is to right-click the block diagram, go to measurement IO and IDAQMX, and then find the read task, and then drag and drop it to the block diagram. So following the settings, there will be a drop-down arrow as shown here in the read task, wherein if you click the drop-down arrow, it will show the polymorphic VI selector, and then we can set the values to analog, and then single channel, single sample, and then DBL or floating point. So next is to drag drag and drop the clear task in the same options or same category in the functions. So after this, we can right click again the block diagram and go to dialog and user interfaces, and then select simple error handler VI. So next is the right click. Next is to right click the data output of the DAQMX and then choose read, and then select create indicator. So rename the indicator current temperature degrees Celsius. So after all those components are placed on the block diagram, we can now wire all the input and output as shown in the diagram below. So next is the answers to questions. So basically there are five different all in all total questions in the manual. So for the part 1 there are 2, however in the part 2 there are 3. So for the part 1, step 10, discuss the content of the temperature file, provide the screenshot of the notepad window, and then label the provided screenshot properly if needed. So step 11 is using the icon help, list down the icons and state their corresponding functions. So part 2, step 21, provide screenshot of the current window or screen after performing the required task. Label the provided screenshot properly if needed, and then discuss what is it all about. So drill 2.1, provide screenshot of the current window or screen after performing the required task. So this required task is all about the modified temperature VI. So after that, label the provided screenshot properly if needed, and then discuss what is it all about. So for the 2.2, again, provide screenshot after performing the required task, and then label the provided screenshot properly if needed, and discuss what is it all about. So for drill 2.1, the screenshot provided is the block diagram, while in drill 2.2 is the front panel of the temperature VI, of the modified temperature VI. So for my answers, so for the part 1, again for step 10, this is the temperature file opened in Notepad. So as observed, the temperature starts from 48 degrees Celsius and then increments to until it reaches the highest. For this case, it's 57. So explanation behind this is that the created temperature file is the destination file where all the results after running the pre-built program is stored. So as seen from the figure, it indicates that the temperature file is in degrees Celsius as well as it is increasing. So the values from the notepad can also be seen in the plot chart in the front panel of the loaded program. So next is the step 11, using the icon help, list down the icons and state their corresponding functions. So for inputs, or the left side of the block diagram, you can see there the open, create, replace file function. So this icon operates like it opens the existing load file in your computer, or creates a new file or replaces an existing file, and then interactively using a dialog box. So second is to concatenate string function. So concatenates input string and ID arrays of strings into a single output string. So the third icon is the write to text file function. This writes a string or array of strings as lines to a file. So fourth is the DAQMX create virtual channel. So this creates a virtual channel and adds them to a task. Fifth is the DAQMX timing. So this serves as a clock where it configures the number of samples to generate and creates a buffer when needed. So last is the DAQMX start task. VI transitions the task to running state to begin the measurement or generation. So for the sub VI, there are 4. So first is the DAQMX read. It reads samples from the task or virtual channels the user specifies. Second is the format into string function. So it formats string, timestamp, boolean, or numeric data as text. It also used to convert a number into a string. So third is the write to text file function. This writes a string or array of strings as lines to a file. So fourth is a logical function or the OR function. Computes the logical OR of the inputs. Both inputs must be Boolean values, numeric values, or error clusters. So for the output or the right side of the block diagram. So first is the DAQMX stop task. So stops the task and returns it to the state the task was in before the DAQMX start task or the DAQMX write. So next is the DAQMX clear task. So this is used to clear the task. So third is the close file function. So basically this closes an open file specified by refnum or reference number and returns the path to the file associated with the refnum. And lastly is the simple error handler VI. So this indicates whether an error occurred within the system. So if an error occurred, it returns a description displayed in the dialog box indicating the error. Next is the step 21 or for the part 2. It provides a screenshot of the current window or screen after performing the required task. So this one is the figure 2.0 showing the front panel after performing the required task or the modified temperature VI. So as observed, there is an output labeled as degrees Celsius. So as shown in figure 2.0 or 2.0, the front panel consists only the output interface which is labeled as degrees Celsius as I mentioned a while ago. So the equivalent component of the output degrees Celsius in the block diagram is the DAQMX read VI, wherein its function is to read samples from the task or virtual channels the user specifies. So for figure 2.1, block diagram after performing the required task. So this is the block diagram of the modified temperature VI. So the figure above shows the final block diagram after performing the required task or step 20 of the laboratory manual. So the block diagram contains the input constant thermocouple, the DAQMX start, task VI, DAQMX read task VI, clear task VI, and the simple error handler VI. So the thermocouple serves as the input in the system. It provides a degrees Celsius input which was set with a maximum of 30 degrees and minimum of 20 degrees at the beginning of the program. So the start task is responsible in the transition of tasks or to begin the measurement or generation of value. Then the flow goes into the read task which is responsible in interpreting or reading the sample specified by the user. So the output pin of the read task is then connected to an output device which is labeled as current temperature degrees Celsius. So the read task is then connected to a clear task and an error handler which is responsible in detecting any error occurred within the system. So for drill 2.1, provide a screenshot of the current window or screen after performing the required task. So this will be the modified temperature VI in the laboratory manual. So this is the modified block diagram for drill 2.2. So the explanation behind this is that there were some components such as conditional statements, string constants, as well as indicators which provides results or output depending on the input of the user. So in particular, the added functions are the greater condition, input terminal for maximum threshold, Boolean indicator, select functions, string constants, as well as string indicator which provides output message to the user. So for drill 2.2, first is the figure 4.0 when max threshold is 26.25. So as seen from the figure, it shows the front panel of the modified block diagram. After modification, there are two conditions or cases which the program will output the message. First is when the input temperature is below 26.26 degrees Celsius, and second is when the input is equal or greater than 26.26 degrees Celsius. In the figure, the temperature was set to 26.25, which turns the LED on as well as displayed a message, "System in danger of overheating, turn on the fan." So for the 4.0, when max threshold is 26.26, it message system is normal, and as well as the threshold exceeded is turned off. So again, for this case, when the input temperature is 26.26, the output of the LED is turned off, as well as displays an output message system is normal. So this ends my presentation for the laboratory experiment 2. Thank you for listening.